Antarctica, a vast ice-locked continent larger than the United States and Mexico combined. This is the coldest, windiest, most lifeless place on Earth, first explored by humans just 100 years ago. Today, this vast wilderness has become a giant laboratory for the most important and cutting-edge science on our planet. Landing at the geographical South Pole, the southernmost place on Earth, feels like visiting another planet. Ahead lies the Amundsen Scott South Pole Station, one of the most sophisticated scientific research facilities ever built. Despite sitting on top of the ice cap at an altitude of almost 10,000 feet, the station is maintained at a comfortable 20 degrees centigrade throughout the year. It hosts scientists from a whole range of disciplines and is home to two of the most powerful telescopes on Earth. As well as housing a high-tech kit, the base provides a life support system for people to rest, work and play in relative comfort. This astonishing building is a triumph of technology and engineering and is as close to a space station as you can find anywhere on Earth. But a station this big needs support. Each summer, a convoy of tractors brings in supplies travelling along a snow road nicknamed the McMurdo South Pole Highway, a journey that takes more than 4 weeks. The goods they bring will help sustain the base for the next 6 months. Not long after the convoy departs, the sun sets for the last time. The Antarctic winter has begun. A long, dark night that will last for months. It's in the polar winter that the comfort and safety of the South Pole Station really comes into its own. Though the peak of research activity is in the summer, the station functions all the year round with a skeleton crew of 50 people who spend the whole winter here. They have risen to the challenge of making a habitable environment in one of the most inhospitable places on Earth with a surprising installation, a greenhouse. Here, fresh fruit and vegetables are grown under artificial lights, while the rest of the continent is in darkness. Regulations prevent soil from being imported to the Antarctic, so the vegetables are grown using a system of hydroponics. Their roots are held directly in contact with water loaded with nutrients.
Inside here, it's a comfortable 25 degrees Celsius. Relative humidity is about 55%. Outside, the temperature will be at least negative 30 degrees Celsius, and as the winter really starts to get going, it'll get as far down as negative 80 degrees Celsius. So it's pretty cold outside. And this will be the brightest environment one can find in Antarctica, I believe.
This greenhouse is so high-tech that the team can control the amount of food and light the plants receive from the comfort of their office in the University of Arizona. But to really appreciate the achievements of modern science at the South Pole, one must go back 100 years to when science and exploration began here. In 1911, Robert Falcon Scott and his team built this hut as a supply base from which they would set off on their quest to be the first humans to reach the South Pole. little has changed. It's as if they only left yesterday. Unlike modern visitors to the South Pole, these men had to bring everything they would need with them. Their crates of supplies came by ship, containing materials to build the hut, as well as food and clothes for the men. 10,000 of these items still remain. All their food came in tins, which still line the shelves today, while the bunks that this 25-man team slept in during their first winter still look much as they did a century ago. While Scott and his men prepared for their race to the pole, the team carried out a variety of scientific experiments. They had brought with them equipment for studying meteorology, geology, and collecting specimens. Over the years, the hut fell into disrepair until recently a team began work on the world's most remote restoration project. Their mission is to save the hut from being destroyed by the ice, as well as to discover more about early science and survival in Antarctica.
The expedition was very well equipped with equipment and technology, and there was also telephone, which they ran across the sea ice and linked various different places together. There's quite an elaborate system of switches and lights, interior, exterior electric light bulbs, which would have been very cutting edge indeed, and an enormous amount of scientific equipment as well, of all manner and all sorts. We're very fortunate that it's survived in the condition it has. I mean, the hut was only intended to last for 2-3 years at most, and here we are a century on. So we have this fabulous opportunity now, if we act quickly, to preserve what's here for future generations.
Scott and his men left the hut on the 1st of November 1911 to begin their journey on foot to the South Pole. Ahead of them lay 800 miles of the most challenging terrain on the planet. The route they chose through the Transantarctic Mountains took them up the mighty Beardmore Glacier. Slowly they traversed its appalling surface until finally they reached the ice plateau. They still faced a further 300-mile trek. The achievement of finally reaching the pole was tainted by the fact that the Norwegian, Roald Amundsen, had got there first. Scott and 4 others perished on the return journey. 16 kilos of rocks and fossils, specimens that they had dragged back with them, were discovered close to where they died. Nobody stood at the pole again for 44 years, until 1956, when the first scientific base was established here. A small party from the United States Navy landed supplies by plane so they could build the first Amundsen-Scott South Pole Station. 6 wooden huts in the midst of the barren ice cap. That same year, a science party overwintered, the first humans ever to experience the longest, darkest winter on Earth. The old wooden huts were replaced in the 1970s with this gigantic dome. But this too has been superseded, its panels dismantled and removed without trace in 2010, as every man-made item must be in Antarctica. The most recent South Pole station is designed to withstand extremes. Its curved sides funnel the wind, and it stands on stilts that can be raised to accommodate the build-up of snow, which accumulates at a rate of 20 centimeters every year. All this is a far cry from the bleak white emptiness that confronted Amundsen and Scott. They would be truly amazed to see what exists here today. Science has come a long way in the last century, yet the goals of those who come here are in many ways still the same. This is a place where scientists look to the skies, releasing weather balloons twice a day to collect vital data about the level of ozone in our atmosphere. The South Pole is also said to have the cleanest air on Earth, which has been sampled here at the Atmospheric Research Observatory for the last 50 years, giving a long-term baseline for gases such as carbon dioxide or CO2, data that is crucial to modern climate science.
Climate change is a really hot topic right now, and it's really important that we monitor the levels of CO2. Basically, we want to know how much it's increasing or how much it's decreasing. Or this long-term record really displays that very well. Especially down here, we get a really good global average because there's no local influences. We can tell what the level is without, being right next to a city.
And it's not just the current climate which can be studied here. The ice at the South Pole is the perfect place to investigate our past. This is the Ice Cube facility, the powerhouse for an enormous underground system of sensors that uses the pristine Antarctic ice as a natural laboratory in which to study the beginning of the whole universe. Ice Cube covers a cubic kilometre, but is buried deep below the surface. A heated drill is used to melt holes 1.5 miles down into the ice cap, a process that takes about 48 hours. Into the holes are lowered chains of photodetectors, which look for tiny ghost-like particles pulsing through the ice. The particles are called neutrinos, formed billions of years ago after the birth of the universe. Neutrinos are extremely difficult to detect, but as they pass through the Earth and enter the pure transparent ice, they occasionally crash into atoms, sparking tiny flashes of blue light that reveal their existence.
Ice Cube is a neutrino telescope. So it's like a regular telescope. We're trying to make an image of the universe, but instead of using light, we're using particles.
What they learn from mapping the direction of these particles will provide a fascinating insight into the cosmos and the very beginning of time. While Antarctica's ice can help us understand our past, it also holds information which is very relevant to the present. This long-range DC-3 plane was built in 1942, but has been fitted with very modern ground-penetrating radar, which can effectively see through the ice. The plane is a mobile lab from which scientists can map the miles of unexplored landscape, not just at the surface, but deep below, where the ice meets rock.
This airplane is called an aerogeophysical platform, and a platform like this allows you to combine multiple data sets. In this case, we have 14 instruments operating simultaneously, and each of them has a role in characterizing the geology and the glaciology in the Antarctic region that we're flying in right now.
Much of the ice that covers Antarctica is over 2.5 miles thick. It cloaks mountain ranges, volcanoes and lakes, and in places its weight depresses the land far below sea level.
It's just incredible, the things that are down there that you would just never know without these instruments. When you look out the window, all you see is ice as far as the eye can see. And you very well may be flying over a mountain range the size of the Rockies. Being in Antarctica is just it's a very special experience. It's an honor to be a part of a program that is requiring such important data for building understanding of our natural environment that's hard to reach.
Far from being static, Antarctica's ice is on the move, flowing out from the thickest part of the ice sheet towards the coast. What's more, the ice is changing fast. It's hard to imagine, but if all this ice melted, it would contribute more than 60 meters to our global sea levels. Scientific programs like this one are vital. We need to know the volume of this ice and better understand how it behaves before we can predict the long-term future of this ice cap and what that, in turn, means for the rest of us. The place where change is happening most rapidly is around the edges of the ice sheet, where the ice flows out over the sea. And that is where much scientific attention is now being focused.
Well, I've been working down here for 25 years, but I have never felt such a sense of urgency as I do with this particular project. We know that sea level is rising right now. It has been rising for the last century, but it's rising faster now than it was before, and we expect that acceleration to continue. To understand what the ocean is doing to the ice, we have to get into the ocean. And the path to get to the ocean is through that ice shelf. So we use a hot water drill to make a hole, just melt a hole all the way through the ice shelf. And through that hole, then we can deploy our ocean profiler.
This ocean profiler is a specially designed recording device which is dropped through the ice sheet to the ocean below. It's a unique and expensive piece of equipment.
It's about as tense a deployment as I've ever made. There's no spares of this thing. So far, so good, but you never really know how it's all going to work out until you're out here in the field doing it.
Over the coming months, the ocean profiler will transmit information about what's happening below this ice shelf back to a lab in Monterey.
It's going to be telling us the type of water that's coming in underneath the ice and the type of water that leaves the ice. And from that difference, we know what it's done to the ice, how much ice has been melted, because it's that melting of ice that thins the ice shelf, and that ice shelf, a thinner ice shelf, can't hold the ice sheet back as well. So once the ice shelf thins, that glacier accelerates. What we're doing down here is so important because sea level all around the world will be affected as Antarctica shrinks. And almost half of the world's population lives close to the coast and is affected by changes in sea level.
Antarctica may feel like the other end of the planet, but anything that happens here affects us all. We may think of this continent as being frozen in time, but in fact, the ice has a life of its own. And nowhere is that more clearly illustrated than at the South Pole itself, which before and since mankind visited it, has continued to be on the move.
All right, first and foremost, I'd like to thank each and every one of you for showing up here today. It's fantastic to see such a large turnout for these traditions of the South Pole. What we're here today for is the annual remarking of the geographic South Pole. Now, as you all know, the South Pole Station, our home, sits on top of a 3,000 meter deep polar ice cap. And that ice cap moves at about a rate of 10 meters every year. Or if you prefer, probably about 2.7 centimeters every day. It is my honor to present to you guys, on behalf of the Winter Over Crew of 2009, the Geographic South Pole marker for 2010. Carries the inscription of the name of every member of the Winter Over Crew. With this, I would like to invite all of you to participate in relocating this marker, the new, accurately placed Geographic South Pole.
The ceremonial marker and Antarctic Treaty state flags serve as a reminder that Antarctica belongs to no one, but is reserved for the interests of science and the progress of all mankind.